for it. It's not a race.
And that's all I got. So.
Okay. Anybody agree or disagree? Thank you. We'll fix it. There's a couple of errors. It took a while to see what you were doing, but I think it's okay. There are some things that are okay.
What is X plus 3?
All right. So I'm going to try to interpret what you did because it took me a couple seconds to see it. But basically, with these things, there are several ways you can do this. With these kind of problems, you don't even have to follow order of operations. I highly recommend that you do follow order of operations, but you can get around it. Order of operations says do all the stuff on the inside first. We have this fraction bar, which is kind of like a parenthesis. So if there was anything to take care of in the numerator or anything to take care of in the denominator, you would do those things first. There's not. But before we take this third power, or everything to the third power, start dealing with they're not like terms, but that's the easiest way to explain it, okay? Take care of the common things. So, technically this negative is like a negative 1. So we've got negative 1 over 5. Okay, taking care of the numbers. I'm just going to kind of extend this fraction out. Now we got m's, okay, same base. There are 9 of these m's in the numerator. There are 10 of them in the denominator. The rule says what? If you got m to the 9th over m to the 10th, what does properties of exponents say? Subtract what from what?
9 minus 10.
Yeah, top exponent, the base stays the same, top exponent minus bottom exponent. And so you get m to the negative 1. What does a negative exponent do?
Makes it all a fraction.
Goes 1 over, same base, positive exponent. All right, that's the rules. But there's an easier way. You've got 9 factors of m in the top. If we spelled it out, there'd just be 9 m's. We got 10 factors of m in the denominator. There'd be 10 of them. How many are in common, top and bottom? 9. So all 9 of those are going to cancel out. 9 of these 10 are going to cancel out. How many's left? But it's in the denominator. It's in the bottom. All right, so we've taken care of all the m's. Technically, there was a factor of 1 there. You know, we factored all the m9s, or m to the 9th out. Now we got our n's. Okay, we got 1 in the top. We got 6 in the denominator. So there's 5 factors of n in the denominator. Technically, a 1 in the numerator. This is what I mean by just kind of taking care of the common things. Numbers, things with the same base. All right, so this is still raised to the third power. So let's just clean this up a little bit. We just got a negative 1 in the numerator. We're just multiplying these fractions straight across. We got 5m times n to the 5th. That's all we can do on the inside of that parenthesis. Now we've got this raised to the third power. So there's a couple of rules happening here. The first rule is we have a fraction being raised to a power. What does the rule say for that?
That you multiply to get into both the numerator and denominator.
Numerator gets the exponent, denominator gets the exponent. All right? Where we're at down here, we also have things being multiplied together. So, If we got things multiplied together, taken to a power, what's the rule say for that? Both of them. A to the n, b to the n. It kind of looks like a distributive property. It's not. Distributive property is specific, a number times this parenthesis where you're adding or subtracting terms. Just everything, each of those factors gets that exponent. So, what we're looking at down here, we've got -1 to the third. The numerator gets that power. We have 5 to the third, m to the third, n to the fifth to the third. Okay, so negative exponent, sorry, that's not a negative exponent, a negative number to a power. What is -1 to the third? It is going to be -1. If you take a negative number to any odd power, it's going to be a negative. Okay? If you take a negative number to an even power, it's always going to be positive. Negative times a negative is positive. Okay, that's 2 powers. It's even power. So just quick ways to do that. Over. 5 cubed is 125. M cubed is just that. Now we got this next problem. Well, we're using all of them on this problem. N to the fifth, that whole thing is raised to the third.
15.
Why?
Because you're multiplying the 5 and the 3.
Yes. This third power means you got n to the fifth times n to the fifth times n to the fifth. That's 15 n's. There's our answer. Okay. Right with that? Any questions about it?